Good morning, everyone. Let me remind you that this Thursday we will have a test. Our test will be from 8 o'clock to 10:30. Basically, your class time. Your class time plus 5 minutes. Now, we will do check-in at 7:45. With the number of students we have in this class, yes, we'll start at 7:45, maybe a bit earlier. I will see. My office hours started from 7:15 anyway. So let's say around 7:40, if I have enough students there, then I will start the check-in process. And what is the check-in process? I will check your picture ID. It doesn't have to be your school ID. No, it doesn't have to be Santa Monica ID. No, it could be your driver license or your state ID, or worse in worse, your passport. Okay, but anything with picture and your name. Okay, and after I check your ID, confirm it's you, then I will ask you to redirect your camera. Okay, of course, it means you need to have a camera. Okay, tomorrow is the day that I need to see you. Not like other days, not like today. Today I don't need to see you. You don't need to see me either, right? But on tomorrow, I need to first check it's you. And then I will ask you to redirect your camera. So please secure your environment. Is it, did I say tomorrow or Thursday?
Tomorrow.
I'm sorry, it should be Thursday. It should be Thursday. Yeah, but tomorrow I have a Monday, Wednesday class taking their tests, but they have different time. They start at 9:30. Their class start at 9:30. Your class start at 8 o'clock, right? Now, so when I say I help you to redirect your camera, you also need to secure your environment first. Okay, like things that you don't want me to see, you don't want other students to see, please move them away from the view. Okay, but I mean, to be honest with you, I don't really think anybody care with your environment. Yeah. Okay. I myself just care about you, about your table, your desk, right? You need to have your test there, your stationery, your calculator, maybe, right? Somebody asked that question again. What kind of picture ID? Your any picture ID like school picture ID, SMC picture ID, okay, or driver license, worse in worse passport, or if you are from other state, you can use your state picture ID. That's fine. You know. Now, once you check in, then I will send the test file to your Canvas email. Okay. So you need to have access to your Canvas email. You need to have access to your Canvas email. A big warning, your last quiz, and I know some of you get really become impatient, and I apologize for that, with me returning your last quiz really late. Like it took me like 2 weeks approximately to give it back to you. That's because too many of you using photomath during your quiz. And please don't do that for your tests. Okay, for your test, no more photomath, please. And no other software to help you doing the problem. Okay, it's very easy for me to make you not able to use photomath at all. Okay, it's just like inconvenient for me and you also. Suppose, for example, if I want to ask you to factor this x squared minus 2x minus 3, right? You can take the picture and then it will factor it for you. Now, what should I do if I don't want you to use photomath? I just change this. I make it plus c. And then as I factor these when c equals to -3, then your photomath cannot do that anymore. Okay. You may be able to cheat me for this test one. You secretly use photomath, and then you secretly able to do it really fast and you survive my test 1. But so far, nobody used photomath able to survive my test up to test 3. No, nobody. Okay. Please don't think that you are so good that your teachers are so bad, so behind in technology. No, no, we know it. Okay, especially we faculties at SMC and West Hello College, we communicate each other. Okay, so once we see something not right, we tell the whole department. Okay, and of course, we don't want somebody who passed this class simply by photomath end up in calculus and expect to pass the class again with photomath, right? Okay, so please, photomath is there not for this level, to be honest with you. If you want to cheat, you can cheat your way using photomath for algebra 1 or algebra 2, but not for pre-calculus. And of course, later on, I get the students complaining that, Thomas, your test is so hard, but implicitly they're saying it's so hard that photomath cannot do it. It's like, duh. Okay, so please, let me tell you last time, don't do that. Okay, do not tell me later on that my test is too hard. After all, I told you that thing that I am hard since the first day of class. That's in my last name, by the way. My last name is Arjuna. Students call me hard, you know. Okay, that's my last name. Okay, but I can also say that those students who say that I'm hard, they just try to cheat, but they just cannot do it. They try to cheat, they cannot do it. Even if they can do it, they try to cheat from somebody who cannot do it, or from a software or app that cannot do it. So how to say it? You know what? They cannot do it this way, and then suddenly they just say me, they just blame me for other thing. Okay, but if you study right, it should be okay. It should be doable. Okay, so please again, do not use photomath. And photomath has some weaknesses. Let me share with you with my announcement, my last announcement, in which I get really, honestly, I get pissed off that I really say that out loud. This is my announcement about some students using photomath. It's just like this, like I took the picture of my question and I see like at least 10 students out of 60 students, at least 10 of you, just copy paste from what you see from photomath. It's just like, what are you doing? You know, I mean, even if you want to cheat, be smarter. Okay, be smarter. Now, cheating from photomath requires you to take pictures from the file and copying through it. It will slow you down a lot. That's one. Second, there are many things photomath cannot do, and you can see it from your solution. In actually, my quiz tool 3, part of that is being directed to detect if you use photomath. Who are the one using photomath? Who are the one who I need to keep an eye in your test 1? Okay, the third one. Now, there are things photomath cannot do as natural as human, and it shows also in your work. Take a look on how they do factoring. Every time photomath try to do a trinomial factorization, it always takes 3 steps, even 4 steps at times. While if we do it as a human, we do that, it will take only 1 step. Okay, and because of that, one reason we have restricted time is to prevent you from committing academic dishonesty. Okay, those who cheat will always need more time. So students who later on say, oh, Thomas, your test is too long. I don't have enough time. Well, if you need time to cheat, of course, you don't have enough time for the test. Okay, I know some students are honest and they still need extra time. That could be because they did not prepare, not well prepared. Okay, but those students who try to cheat using photomath, they always ask for extra time. Okay, and they were in the camera, on the camera, they will behave strangely. That I have to talk to them. It's like, hey, what are you doing? Why don't you just focus on your test? Why do you need to touch your phone all the time? Okay, so consider yourself warned if you are one of the person who use photomath. Okay, and I think, to be honest with you, it will be a bit too late if you just barely start to repent. But give yourself a chance. Okay, in 2 days, prepare yourself to be independent of photomath. Okay, the third one. Now, once you are done with your test, let me know by chat that you are done, that you're about to scan. Do not scan until I give you a go ahead. Okay, do not scan until I give you a go ahead. Now, depends on the view I have on my camera, like the view, like when I see you taking the test. Okay, if I can see your test, I will ask you just scan right away. But sometimes the view is not really clear, so I want you to do a couple things before you do the scanning. Well, basically, before you start scanning, let me know. Okay. Now, the fourth one, make sure you know how to scan to a single PDF file. I still have students from West LA College told me this. Thomas, I forgot how to scan it to PDF. I was just like, what? Okay, how many quizzes we already have? 3 quizzes, and you still don't know how to convert that to PDF. Well, I did it different way. You said, well, I told you not to do it different way. Now you wonder how to do it, like what happened to 9 pages. So what happened is like quiz 0, some of them actually type it to computer. Okay, but quiz 1, you cannot do that anymore. But this person still tried to do that. Quiz 2, 3, this person still tried to do that. And then on the test, that person's like, I don't know how to do that, Thomas. It's so different. It's like, I told you, imagine what happened if you have a test. You know, it's like you didn't listen to me, and all of a sudden you ask me to understand you. Uh-oh. No, that's not good. Okay, but most of you are actually fine though. Okay, most of you are actually fine. Just like at West LA College, when I give them the test, I have only one case of students kind of like getting mad with me for giving such a long test. I was like, hey, I went over the test in class, so it's not something new that my test will be long, right? Okay. Well, of course, that students just don't show up and then suddenly just show up on the test day. Okay. Now, the following is what I observed and also what some students told me, a very good input. If you already have Canvas for Students app on your phone and you have Cam Scanner, or really get used to it. Okay. Now, some of you only have Canvas for Students for other class. Some of you don't have Canvas for Students, but you have Cam Scanner. Now, imagine if you have both of these apps on your computer, on your phone, okay, and your Wi-Fi signal is strong. Then what you can do is this. You can take the picture using Cam Scanner, and then you scan it to PDF, okay, and upload it directly from your phone because you have Canvas for Student already, right? Now, this way of scanning, converting to PDF, and uploading seems to be the fastest way I see so far. Okay. Now, here's the thing. Why I mentioned this, because some of you did this. Some students actually scan it using Cam Scanner, and then once they get the PDF file, they send it to themselves and then upload it using their PC, using their computer. Okay, which is okay, but in my opinion, that's you need to upload it to your email anyway. Why don't you just upload it to your Canvas for Student? You see what I mean? Okay. Now, if you already have Canvas for Student app on your phone, you're just missing Cam Scanner, then you may want to learn how to use Cam Scanner. Okay. And then you basically combine these two apps. Okay. But please, if you didn't realize this and you want to try this, please practice between today and Thursday. Make sure that on Thursday you already know how to use it. Okay. But this is just an advice though. This is just an advice. You don't have to do it this way. No. This is just an advice. Okay. Yeah. But most students that I saw during the test, even if they use regular scanner and they upload it using their computer, they're still fine. Okay. They're still fine. Okay, it's just like when I did comparison, students using this technique is always the one, the fastest one, always the one who write into the file if they have tablet, let's say, right? So they wrote into the files, Once they're done, they just save it as PDF right away and then upload it. That's the fastest, of course, right? But if you need to manually scan it, then this technique will be the second fastest. Okay. My concern sharing with this with you is that so that on Thursday, you are not being slowed down by the submission procedure. Okay. You can be a perfect student that you get everything right, but then you don't know how to upload it, right? You don't know how to scan, then that will slow you down and maybe I don't even accept your submission, right? Okay. Now, next, your upload should be finished by 12:15. 12:15 is not when you start the submission by. No, you're supposed to be done. Everything should be done by that time. Everything should be done by that time. Okay, so 12 o'clock, you need to stop. 12 at noon, you need to stop. And you have 15 minutes to scan it to PDF, upload it to Canvas. Okay, your upload should be finished by 12:15, not when you start submission. No, that's not. Okay, now next. What happened, Thomas, if I need to do a makeup test? Usually this is for those people who don't really attend my class and they forget that we have a test. So they want extra time to study. Okay, now keep in mind that you have to formally request for makeup test before this Friday. So let's say you missed the Thursday, but Friday you have to let me know already before midnight. Okay, and your makeup test will be from 8 o'clock to 10 o'clock, 10:30 on Saturday morning, basically the same time with our class. Okay, but it will be on Saturday. Okay, I will give you, the reason I want you to formally send me the request so that I can also reply you using Canvas email, the link for the makeup test. Okay, it's supposed to be on our Canvas though. Okay, the link's supposed to be on our Canvas. The time will be the same to ours. So on Thursday, your check-in is 7:45. If you do a makeup test, that will be 7:45 also. Your test start at 8 o'clock on Thursday. If you do a makeup test, you will start at 8 o'clock. Okay, the test end at 10:30. If you do it on Saturday, you will also end at 10:30. Submission should be done by 10:45. Then your submission should be done by 10:45 also on Saturday. Now, keep in mind that there's only one makeup test. Only one makeup test per person per semester. Read my syllabus again. I only give makeup test for test 1 or test 2 or test 3 or final. So if you decide to do makeup test for test 1, then you don't have makeup test available for the rest of the semester anymore. Okay, so during the taking a test, we have to turn on video and show the test. Yes, you need to show during the test, not only at the beginning, during the test, throughout the test, you need to show the test on your desk, and then you are working on it. I don't need to see your face anymore. I need to see your face compared with your ID only at the beginning. Okay, but after that, I will ask you to redirect the camera to your desk. So let me see. I wonder if it will work with mine. Give me a second. So let me try if I can use mine. Okay, so at the beginning, I will do this. Okay, and then, oh, you know what? This is my ID. Okay, I show my ID. Okay, Thomas, make it higher. Once I check your ID, then I will ask you to redirect your camera so that it shows my desk. And it will stay like this for the rest of the class. Until you are done, of course, then, hey, Thomas, I'm done with my test. Can I scan it? Now, if I happen to not have a good view on your test during the test, of course, I don't want to bother you too much for that. Then I may ask you, okay, can you show me page number 1? Okay, this is my page number 1, like that. Okay, and I will take the picture of that. Okay, show page number 2. Okay, this is my page number 2. So on and so forth. Okay, you will have 9 pages, by the way. You will have 9 pages, and it's the same material with my previous tests, usually only 4 or 5 pages. Okay, but because during the pandemic, I know some of you may need more space when you write it on your own, right? Then I kind of space it out so that what happened is like from 4 page becomes 9 pages. Can I use my iPad during test and send it on Canvas? Yes. You can use your iPad during the test, but send it on Canvas. Now, the thing is when you use your iPad, there's a chance I won't be able to see it clearly on my camera. So I may ask you to show me on your iPad what you write before you do the submission. Okay, before you submit it, I may ask you, hey, show me what you have on your first page. Show me what you have on your second page. Okay, now that's for the tests. Any other question? No more question? Yes, I may even bother you. So, so here's the question from the chat. If I use iPad, then I have to ask you before submit, right? Not only if you use iPad. In every case, before you submit, you need to let me know. Okay, then once you let me know, then I will see from the camera. Actually, throughout the test, I will observe you and see, oh, you know what? I want to see this person's test before he or she submitted. Now, if you are using iPad, then very likely I will ask you to show that to me also. Okay, yeah. Throughout the test, you will be recorded, and I will record it not using Canvas. If I record it using Canvas, then other students can see what happened with you, right? No, I will record it using my personal recording. Okay, yeah. I cannot adjust the camera to the angle you want. You figure out. You figure out. Okay, that's something I mentioned since the first day of class. Yeah, you figure out. Okay, you figure out. Well, I understand. There are some situations like that. And that's the very reason I mentioned that on the first day of class, that your camera should be able to show me your face first, and then later on show me you taking the test. Okay, so what happened, Thomas? I only have this camera, then get another camera. You can log in using 2 Canvas. So one of them for the camera for Zoom and the other one for you to take the test. Yes, it's possible. And I did mention this on the first day of class too. Okay. I mean, I'm surprised that you're surprised. Okay. No, that's something I mentioned before. Okay. I don't know how many times I have to mention it though, because I mentioned it again and again and again and again still. But like, why all of a sudden you think that you're different? I'm not referring to only one student. I'm referring to a lot of students. Okay. But Thomas, I have this situation. You know what? You need to adjust. Okay. I mean, there are many ways to adjust. Okay. But what I need is I need to observe you during the test. Okay, I need to make sure that the integrity of the test is at least being maintained as much as possible. Okay, it's already a big compromise that we take the test at home, right? Okay, at your own place. I just need to make sure that it's you taking the test and you are not getting help from anybody else. It's open book anyway, open note, open book, right? Okay, so I just need to make sure that you are taking the test not with help of anyone, and of course not with that photo math again. Okay, now can you feel that how much I hate that photo math? If photomath can help you passing this class, I will just let you to use that, but it's not. Nobody passed my test 3. Not even test 2 as I know. But even if they survive test 2, the average will be so low that once you pass, they took test 3, their grade is beyond any help. I don't want to wait until you are in that situation, then tell you, you know what, if I were you, I drop the class. No, I'm not waiting until that time. Before that happened, I warn you ahead. From what I see in the past, no, don't do that. Okay, but for the camera, it's only just to maintain the integrity of the test. This is the only time I need to see you and you taking the test. Okay, but try to figure out. Borrow somebody else's camera. Borrow somebody else's camera or phones just for that 2.5 hours. Okay. Other question? Yeah, good thing we go over this again today, right? You don't want me to go over this on Thursday, and then Thomas, why you mentioned that last minute? Even if I do it on Thursday only, I did mention it on the first day of class, but I go over that today so that you are aware what you need to prepare in these 2 days. Okay, I hate to do this though. Trust me, it's like if this is on campus, it will be a lot easier, right? You just need to show and take the test, and that's it. You don't need to worry about Canvas. You don't need to worry about scanning it. You don't need to worry about the signal. What happened if my Wi-Fi is not good? What happened if my internet connection suddenly go down? What should I do? And right now, you need to consider that. Okay, what happened if your internet connection suddenly down? Then use your phone. Okay, but Thomas, it's so last minute. Why do you finish last minute? It's like this. It's like this. I understand many bad things may happen last minute. And in fact, bad things always happen last minute, if you think about it. Okay. Now, what I want to let you know is you are the one should be get ready for that. Okay. Now, so far in 1 year, actually, yeah, 1 year plus 5 days since last year, I never have such case that suddenly internet connection went down during the test. No, I never have that case. Okay, so speaking about probability, what happened to you? What can that happen to me this Thursday, Thomas? Maybe, but if it happens to you, it must be happen to you only, not to the rest of the class. Okay, so in other words, I cannot control your environment. I cannot control your internet connection. It's your internet connection, so you be aware with that. Okay, but so far we have no issue with that though. Okay, because our tests usually usually on weekdays. Okay, and those internet provider company, if they do any maintenance or upgrade, they usually do it last minute. Like on I mean on during the weekend, not weekdays. Okay. Okay, it's half an hour already to just to explain this info for test 1. Other question? Please let's clear it up once and for the rest of the semester. I want your test to go smooth. Yeah, I want your test to go smooth. Like you just take the test. I really wish I can really record a student who take it very smoothly. And I have a lot of those students, but it's something to do with their privacy. You know, that's why I don't want it. Even I already have some students actually allow me to do so. I say, no, that's actually too much privacy that I will put on internet on you, you know, but most of them actually quite very smooth. Okay, and I have my own plan. What happened if this happened? What happened if that happened? Okay, as long as you stay online, stay on Zoom with me, then anything happens, we can take care of that. Okay, the only time I cannot really help you if your connection is down. That it never happened during test anyway, unless you purposely log off. Okay, well, anyway, let's start with the material then. What we will go over today, we'll go over 3.3b. I did 3.3a on last Wednesday. Not your Tuesday, Thursday class, but I did say in my discussion board on last Thursday. We didn't have class, but I used Wednesday to replace the question and answer. And those are actually quite easy to follow. I hope you already watch it. And this is just the continuation of that. From 3.3, number 23. I will do these 8 problems. Number 23. The question is find the zeros of am I sharing the correct one? Okay, find the zeros of, and I'm recording, right? Fx equals to x squared plus x minus 12 being cubed, and then x squared minus 9 being squared. I need to factor this further, right? I need to factor this further. So fx is equal to x plus 4, x minus 3 to the power of 3. And this guy will be x plus 3, x minus 3 squared. So that's x plus 4 to the power of 3, x minus 3 to the power of 3, x plus 3 to the power of 2, and x minus 3 to the power of 2. Oh, we have the same base there. So x plus 4 to the power of 3, x minus 3 now becomes to power of 5, right? And then we have x plus 3 squared. Now we linear factor the function. Then once we get the factor, then we get the zeros. The zeros are x equals to -4 with multiplicity of 3. -4 with multiplicity of 3. X equals to 3 with multiplicity of 5. And x equals to -3 with multiplicity of 2. Okay, that's all they want us to do though. That's all they want us to do. Now, the thing is, if I want to follow up from this question, the follow up, suppose I want to graph this function. Suppose I want to graph this function, then I already have, let's do the sine graph first. The -4 with multiplicity of 3, -3 with multiplicity of 2, and 3 with multiplicity of 5. Now, when x equals to 0, what is the sign? When x equals to 0, I will get negative. How do you get that so fast, Thomas? Just plug in F0. F0, that will be 4 cubed, that's positive, -3 to the 5th, that's negative, and 3 squared, that's positive. So that's negative, right? The total is, the product is negative. So when x equals to 0, the y-intercept is negative. Now then, using the multiplicity, if the multiplicity of that critical number is odd, then I change the sign. If the multiplicity of that critical number is even, I don't change the sign. Okay, so that tells me later on when I sketch the graph, let me move this a little bit to the left. When I sketch the graph, then the function looks like this. -4, -3, and 3. To the left of -4 is positive, but it's multiplicity of 3. So when it cross the x-axis, it will actually curve like x cubed. And then at -3 is multiplicity of 2, so it will curve like x squared around that critical number. and then it goes down like this. This is multiplicity of 5, so it will curve like that. That's the graph approximately. Okay, now the thing is, if you try to use graphing software to graph that, then you will just see lines instead. You will see lines. Why? Because the graph is actually very, very tall. Okay, very, very tall, such that if you try to graph that to scale, then you will not see this. This is the summary of important ingredients of this function. Okay, the x-intercepts, okay, and the y-intercept will be what? Such a very big number, right? Negative something very, very big. You see? Okay, but when I ask you to sketch, this is what I want to see. Okay? Now that's for this question number 23. Let's go on with number 25. Number 25, we have find the zeros of fx equals to x to the 4th plus 7x squared minus 144. Find the zeros of that. Oh, wow. I set fx equals to 0. And then seems like we can use quadratic-like equation, right? Okay, quadratic-like equation, or if you factor it directly with that quadratic-like equation in mind, that's also fine. I think this is plus 16 minus 9. Okay, so let me factor further. This is x squared plus 16, x plus 3, x minus 3. So the zeros are x squared plus 16 equals to 0. So x squared equals to negative 16. X equals to plus minus square root of negative 16. That's plus minus 4i. And we have x equals to negative 3. X equals to 3. I need to break this up. This is x equals to 4i. X equals to negative 4i. Those are the zeros. Okay, so the zeros are, let me summarize that. X equals to 4i, x equals to negative 4i, x equals to negative 3, x equals to 3, all with multiplicity of 1. You see that this function is degree of 4. It has 4 zeros, right? Now, but let me go on as a follow-up question. Follow-up question. Suppose I want to graph that. What are the x-intercepts? The y-intercept is 0, negative 144. How about the x-intercepts? Now, as I mentioned before, not all zeros becomes x-intercepts. Only the real zeros. Okay, so even though we have 4 zeros here, but 2 of them complex numbers, right, with imaginaries. So the x-intercept only 2, negative 3, 0, and 3, 0. Okay, so when I try to do the sine graph, negative 3 and then 3, both of them critical number, both of them zeros. The y-intercept is negative 144. Each of the critical number are multiplicity of 1. So when I sketch these, The y-intercept is negative 144, 0, 100, negative 144, x-intercept 30, negative 30. And if you look at that again, this function is actually an even function, right? It has y-axis symmetry, right? How do we check if a function has y-axis symmetry? Now that's part of your test one. Okay, you check f negative x. Okay, replace x by negative x. Basically, you reflect that with respect to y-axis and see if you get the same function back. And in this case, that's true. Okay, once you are able to show that f negative x equals to fx, then the function is even function and it has y-axis symmetry. Okay, so whatever happened on the right-hand side, that's what happened on the left-hand side too. Okay, it may look like this. Like that. Okay, now the thing is why we have this, Thomas. I just make it variation. Okay, it may just look like this. It may just look like that, and I'm totally fine with that. At this level, we don't learn how the curve, how the graph being curved when you have imaginary zeros. We have not learned that yet, and we don't need to learn that until you get to calculus class. Okay, that's for number 25. Let's go on with number 27. Number 27. Show that the number is a zero of fx given multiplicity. So let fx equals to x to the fourth plus 7x cubed plus 13x squared minus 3x minus 18. And x equals to negative 3 is a zero with multiplicity of 2. Okay, that's the question. Now, what they want us to do is find all the zeros. Basically, factor it. Factor into linear factor. Now, this phrase, linear factor, is a special term. Okay, basically, you will need to write them into linear factor. Okay, but in this question, we actually will do, implicitly, I will teach you a technique of reducing polynomial. How many zeros this function is supposed to have? This function is supposed to have 4 zeros because the degree of the polynomial is 4. Now, they give us 2. They give us 2 zeros. Okay, now, so notice that because they give us zeros, x equals to negative 3 is a 0. That implies x plus 3 is a factor. Now, using this factor, I will divide the polynomial. Basically, I will reduce it by x plus 3 twice, such that I get fx equals to x plus 3 squared times something, something, something. Right? It's a 0 with multiplicity of 2. So x plus 3 squared is a factor, right? Okay. Now, that also means I can use x plus 3 to divide this polynomial twice, and the quotient will be degree of 2. Now, from there, I can continue. This is degree of 2. And from there, I can continue factor it further. Basically, one of the big plan is find enough number of zeros such that you can reduce that polynomial. You factor that polynomial down to degree of 2. Once it is a polynomial degree of 2, then we can find the zeros more, either by factoring or by completing the square or by formulas. Okay, now let's start. Let's start. I will use synthetic division. 1x to the fourth, 7x cubed, 13x squared, negative 3x, negative 18, divided by x plus 3. Now, so here I divide by x plus 3. Implicitly now the function fx becomes x plus 3 times x cubed plus 4x squared plus x minus 6. Now, they told us that x equals to negative 3 is a 0 with multiplicity of 2. So I still can divide this again by x plus 3. Okay, so implicitly right now my function fx is x plus 3. That's the first x plus 3 I divide by. And then this polynomial now becomes x plus 3 times x squared plus x minus 2. You see that? Now, this is a degree of 2 already. So we can actually factor it if you want. Okay, so now we have fx equals to x plus 3 squared times x squared plus x minus 2, which I can factor further. Okay, now this is what we call linear factor. What is linear factor? Linear factor if you have, so going back to definition, the linear factor of fx equals to ax to the n plus blah, 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 blah is equal to the leading coefficient always separated, and it will written as x minus something, x minus something, x minus something. Okay, with some exponent, of course. Depends on the multiplicity. Okay, so this is what we call linear factors, and the zeros are x equals to negative 3 with multiplicity of 2. That's what they told us. X equals to negative 1, x equals to 1, both with multiplicity of 1. Okay, so even though the question just to find all the zeros, but implicitly we are using the 2 zeros they told us to factor that x plus 3 squared out, and the remaining becomes a quadratic, which we factor further. Okay, so notice that they help us with 2 zeros. Okay, if we want to sketch this graph, the graph of this function, we need to find all the zeros, right? Okay, we need to find all the zeros. For now, they give us 2 zeros and we get the remaining. Okay, Now suppose then I go on with the follow-up. Suppose we want to graph this function number 27. Okay, the y-intercept. Let me write the function again. And the y-intercept will be 0, -18. Okay, how about the x-intercepts? The x-intercepts are -3, 0, -2, 0, 1, 0. How about the sine graph? Just to help us graphing it better later on. -3, -2, 1. -3 is multiplicity of 2. The y-intercept is negative. So change sign here because 1 is a 0 with multiplicity of 1. -2 is a 0 with multiplicity of 1, so I change sign. -3 is a 0 with multiplicity of 2, so I don't change the sign. If the multiplicity is even, I do not change the sign when I jump across that critical number. Now, then when I try to sketch the graph, the y-intercept is 0, -18. X-intercepts are 1, 0, -2, 0, -3, 0. And from the sine graph, we know the graph will look like this. -3 is a 0 with multiplicity of 2, so it will behave like x squared there. -1 is a 0 with single multiplicity, so it will just cross it linearly. 1 is a 0 with single multiplicity also, it will cross it linearly. So that's the graph approximately. So you see that between -infinity to -3, it's positive. Hold on, where did I get? My bad, this should be -3 and this is -2. So from -infinity to -3 is below above x-axis. -3 to -2 is above x-axis. From -2 to 1, it's below x-axis. And 1 to infinity, it's above x-axis. The main goal of this 3.1 to 3.4 is the main goal is to graph the function. Basically, you need to know how to factor it also, and all those theorems that you heard in my lecture. Okay, now they already help us with 2 zeros. In the next section, 3.4, they don't give us any zeros. We will be the one who look for those. Okay. Now, let's go on further. That's for number 27. What other question I would like to go over? Number 29. Let fx equals to x to the 4th plus 5x cubed plus 6x squared minus 4x minus 8. And they told us that x equals to -2 is a 0 with multiplicity of 3. They give us 1 0 too many. It's degree of 4, but they give us 3 zeros, right? So if we divide by x plus 2 3 times, the remaining will be just a linear. Okay, let's do it. So 1x to the 4th, 5x cubed, 6x squared, -4x, -8. -2 is a 0 with multiplicity of 3. So I will do it 3 times. Okay, I do it again. And I can do it again. So what those means, Thomas? Well, that's why I need you to learn very well with that synthetic division. Now, originally, this fx is equals to x to the 4th plus 5x cubed plus 6x squared minus 4x minus 8. That corresponds to this part here. Then what does this one mean? It means the fx has x plus 2 factor out. And the one here, you factor that x plus 2 further from that x cubed something. So this part here now becomes here. And this part here becomes fx equals to x plus 2, x plus 2. So the yellow one, this becomes that one. Okay, and then this guy becomes this. Okay, so the linear factors is fx equals to x plus 2 cubed, x minus 1. So those are the zeros. Zeros are x equals to -2 with multiplicity of 3 and x equals to 1 with multiplicity of 1. Follow up, how do we graph this? The sine graph, -2 and 1 are critical numbers. The y-intercept is negative. And each of the zeros has odd multiplicity. So when I try to sketch the graph here, so it will look like approximately like this. -2 is a 0 with multiplicity of 3. So when it crosses that x equals to -2, it will cross like x cubed. One is a 0 with multiplicity of 1. So when it crosses 1, 0, it will cross as linearly. The y-intercept is -8. So this is -8 here, 0, -8. That's what it looks like. Okay. I think I already go over things that I need from this section, this part. Let me just cancel number 31. That's very similar. A lot easier instead. Instead, I go to the Scarce rule of sine. Among all theorem that we learn in this polynomial, the Scarce rule of sine is one of the oldest. Like fundamental theorem of algebra, far-end behavior, remainder theorem, factor theorem, and all those theorems. Among all, the Scarce rule of sine is the oldest one. Okay, so you imagine that algebra already so advanced since the Scarce time. Okay, this is the same guy who invented Cartesian coordinate system. The same guy. Then the word Cartesian comes from this Descartes. Okay, Cartesian coordinate system comes from this guy who invented. Now, let's review again what the Descartes law of sine says. Let's first define definition variation of sines. Now, variation of sines of a polynomial is the number of times the sines of the coefficients of that polynomial changes. Okay, but some warning that the order, the degree, the polynomial needs to be in descending order. So for example, I'm about to do number, I think I want to do 3 questions, number 33. Okay, number 33, let's see how many change of sign first. Okay, number 33, we have polynomial px equals to 4x cubed minus 6x squared plus x minus 3. Okay, so what is the variation of signs of px? What is the variation of signs of px? We see like this is positive. It's already in descending order. So x cubed, x squared to the power of 1 constant, right? Okay, once it is in descending order, then you take a look on the coefficients. Okay, positive becomes negative. That's 1 time change. Negative becomes positive. That's 1 more time change. That's 1 more time change. So the variation of signs of px is 3. Okay, our textbook actually used this phrase, the number of variation of signs. Number of variation of signs. Other textbook, they just say variation of signs is 3. Okay, now in Descartes' rule of signs, you will also encounter, you need to find the variation of signs of p negative x. So p negative x is equals to 4 times negative x cubed minus 6 times negative x squared plus negative x minus 3. That is negative 4x cubed minus 6x squared minus x minus 3. Okay, you see that the sign coefficients does not change, does not change, does not change. So number of variations of signs of px is 0. Okay, now those are the definition and example of what we mean by variation of signs. We will do this more. Okay, but let me quote first what is the Scarce rule of sign. You can see that on my lecture. You can also see that on page 206. On page 206, let me quote that. Okay, let Px be a polynomial, with real coefficients. Then, first one, the number of possible zeros of sorry, I missed a word. Possible positive real zeros of Px. How many zeros? From fundamental theorem of algebra, number of zeros equals to the degree of the polynomial. Now, the Scarce rule of sign actually break it down even further. How many of them will be positive? How many of them will be negative? Okay, and it says the following. The number of positive real zeros. How many real zeros on the right-hand side of y-axis is equal to the number of variation of signs of Px or that number subtracted by an even number. So if we look back to that number 33, right above, you see that here, number 33, right? Okay, the variation of signs of Px, number of variation of signs of Px is 3. Now, what does it mean? Then Px has 3 positive zeros or 3 subtracted by an even number, in this case subtracted by 2, or 1 positive zero. Px is degree of 3, right? According to the Scarce rule of sign, then this Px will have 3 positive zeros or only 1 positive zeros. 3 positive zeros or only 1. The number of variation of signs or that number subtracted by an even number. Thomas, what happened if my variation of signs is, let's say, 6? Let's say my variation of signs is 6. So how many zeros it has? How many positive zeros it has? So it possibly have 6 positive zeros or 4 or 2 or nothing. So just keep on subtracting by an even number until you reach 1 or until you reach 0. Why we cannot have negative, Thomas? Well, the number of things cannot be negative, right? Okay. We cannot say, oh, how many children you have, Thomas? I have -2. No, right? Okay, it must be a positive or 0, but it tells us specifically how many It possibly have. Okay. In other words, this polynomial px for number 33 cannot have exactly 2 positive zeros. No, it must have 3 or only 1. It cannot have 2. Now, the second part of px of this Descartes rule of sign is the number of possible negative zeros, negative real zeros. It's redundant there actually. Once it is negative, then it must be real. Of px is equal to the number of variations of signs of p negative x. Okay, so for the positive one, you observe px. For the negative real zeros, you observe p negative x. You basically reflect that with respect to the y-axis and see what is the variation of sign. Or that number subtracted by an even number. Okay, so for number 33, we see that the number of variation of signs of p negative x is 0, right? Okay, so px has no negative 0. But Thomas, hold on. Well, do we really need to do part 2? Because fundamental theorem of algebra says that the number 0 should be equal to the degree, right? So if the variation of signs for px is 3, then variation of sign for p negative x should be 0. No, that's not really true. That's not really true. I know what you mean. Some of you may think that the total, this guy and this guy will be equals to the degree. And the answer is no, that's not true. Okay, we have a situation where the degree is, let's say, 5, but total variation of signs for px and p negative x is not even 5. Okay, we will eventually touch that though. But let me go back a little bit to what we have done earlier and do such kind of observation. Let's say we look at this guy here, number 27. Let me copy that. Let me copy this and do such observation. So for example, number 27, we already have that polynomial fx, right? So let's see how many possible positive zeros does fx have. And we see how many times the sign changes once it is in descending order. No change, no change, one time change, no change. So here we have 1 positive 0. How many possible negative zeros does fx have? Then we need to observe f negative x. So you replace x by negative x and simplify. You will see the following phenomena. If the exponent is even, you basically don't change the sign. If the exponent is odd, you change the sign. Thomas, I don't know what you mean. You substitute that first, and after a while, you will see that if the exponent is even, the term stays the same. If the exponent is odd, the sign changed. If the exponent is even, you don't change the sign. If the exponent is odd, you change the sign. But that's simply because of the effect of negative x to even power and to odd power. Okay, now then, well, that's just a little side note. Now then, let's see how many times the sign changed. That's one time, another one time, not here, but here. Okay, so it must have 3 or only 1 negative zeros. Now we did this earlier. They told us how many zeros it has, right? Number 27, we get this. I want you to do comparison. Compared to what we did earlier. Notice that the negative zeros are this guy and this guy. So you see a total of 3. 2 of them -3 and 1 -2, a total of 3, right? Okay, now 1 positive zeros refer to this. So we have 1 positive zero, x equals to 1 with multiplicity of 1, okay, and 3 negative zeros, -3 with multiplicity of 2, and -2 multiplicity of 1. Now, the Scarce rule of sine has a purpose of telling us how many zeros we should get to the right of y-axis, how many zeros we should get to the left of y-axis. Okay, now the rest are complex. So remember I told you that the total doesn't have to be equal to the degrees. Let's take a look on this. For example, if I have let px equals to x to the 6 minus 1, the n equals to 6, right? Okay, now what is the change, the variation of signs? According to the Scarce rule of sine, number of positive zeros is only 1, right? It's only 1 time change of sign, right? And how about number of negative zeros? And we observe what is p negative x. P negative x is negative x to the 6 minus 1. That is x to the 6 minus 1. It's also only 1 time. But it's supposed to have 6 zeros, Thomas. If one of them positive and only 1 negative, where are the rest? Then that must be complex zeros. Okay, so the number of positive and number of negative zeros, if they don't add up to the degree, then the rest must be complex zeros. And you will observe that the number of complex zeros always even number, always even. And it has something to do with a theorem we see in 3.4, conjugate zero theorem. Okay, let me do one more example from here. Let me do I did number 33. We can do number 35 and then number 39. And then I give myself a break. Number 35, we have this polynomial px equals to 4x cubed plus 2x squared plus 1. Number of possible positive zeros is nothing, right? There's no variation of sign. How about p negative x? This will be negative 4x cubed plus 2x squared plus 1. Only one time. So the number of possible negative zeros is only 1. Now from there we see that the number of complex zeros will be, for sure, is 2. In other words, it will have only one X-intercepts. And that X-intercept will be to the left of the Y-axis. Now, it doesn't tell us what are the X-intercepts, but it tells us how many X-intercepts we should get and where are those. Number 39. Px equals to x to the 5th plus 4x to the 4th plus 3x cubed minus 4x plus 2. Thomas, we have a skip here. We are missing x squared, just like here. We are actually missing x, right? Missing x term, but that's okay. You just go on. You just go on. Like you have 0x there or 0x squared there, right? But no, it doesn't affect the change of sign. Okay, now how many times the sign changes here? 1 time and another 1 time. So possible number of, I think just possible zeros, possible positive zeros. Why I keep on writing them? It's either 2 or nothing. How can we know complex zero, for example, before 1 and for the number 35 one? The total, the degree is 3. So it should have 3 zeros, right? It should have 3 zeros. But if none of them positive, only 1 negative, then the remaining 2 must be complex. The total has to be equal to the degree of the polynomial. Like the one here, polynomial, this example, it's degree of 6, right? So it should have 6 zeros. But when we look at the Scarce sign, only one of them positive, one of them negative. The remaining 4 must be complex. Okay, so the total should be same as, not the coefficient, but the same as the degrees. Okay, the same as the degrees. Degrees of 6 should have 6 zeros. Okay, but then how many of them positive, how many of them negative, how many of them complex? Now, then let's take a look, continue from this number 39. P negative x will be negative x to the 5th plus 4x to the 4th minus 3x cubed plus 4x plus 2. change 1, 2, 3. Okay, so possible negative zeros. It's either 3 or 1. Okay, possible number of positive zeros, possible number of negative zeros. That's actually the correct wording. Okay, that's for this section. Let's take a break. We come back at 9:35. At that time, we will work on 3.4. 9:35. I think we are done with this, right? If you need to take a note, go ahead. But then section 3.4 is something we'll do after this. Okay, on this 3.4, we will deal with fundamental theorem of algebra, basically the number of zeros and linear factoring and conjugate zero theorem. What conjugate zero theorem says is the following. Conjugate zero theorem says the following. Let Px be a polynomial with real coefficients and z equals to a plus bi is complex zeros. Then the conjugate the notation for conjugation is that a minus bi is also a zero. Okay, now let me explain what the book means with this, and then later on the extension of this conjugate zero theorem that our textbook didn't cover. Okay, so basically it says the following. So for example, if let's say 2 plus I is a 0, then 2 minus I is also a 0. Okay, if a complex number is a 0, then the conjugate of that complex number is also a 0. Is it okay? So if, maybe another example, if 3 minus 4i is a 0, let's say even with multiplicity of 2, then the conjugate is also a 0 with multiplicity of 2. It's like buy one, get one free. Think of it that way. Okay, they always come in pairs. Now, that's what our textbook is saying. But a conjugate zero theorem is actually more general than just complex in sense of complex number. It's actually also the following. If Px be a polynomial with rational coefficients, not only real, rational not only real but rational, like a fraction, okay? And x equals to a plus square root of b or minus square root of b is a 0, b is not a square number, then the conjugate a minus square root of b is also a 0. And we see this actually for those polynomials that we cannot factor. Like for example, if 2 minus square root of 3 is a 0, that's still a real number though. That's not complex number. That's a real number. It's just not rational. Okay, it's not rational, but it's real. Then the conjugate 2 plus square root of 3 is also a 0. Okay, they always come in pairs. And you can imagine some of our, let's say this one, further example. Suppose I have non-factorable polynomial. Okay, and when we try to find the zeros, notice that I need to use complex, I need to use completing the square for this, right? So x minus 2 equals to plus minus square root of 10, right? Okay, that 10 is not a square number, right? Okay, so you see that the zeros are a pair of conjugate real numbers. So those numbers are x equals to 2 plus square root of 10 and x equals to 2 minus square root of 10. Basically, put it this way: if you have a 0 that has a conjugate, then the conjugate must also be 0. In short, if a 0 has a conjugate, then the conjugate is also a 0. Of course, there's some limitation on what are the coefficients of that polynomial. But for the level of, for the type of polynomial we deal in this class, this is always true. Okay. If you invite somebody who is already married, then you must invite the spouse also. Okay. Like if you invite me to your wedding, for example, right? Then I will come together with my spouse, right? Or you may even say, you don't have to get married, Thomas, just simply because you are dating somebody already. You usually say you are invited, you and your important one are invited, right? For example, right? Basically, if that person has a conjugate, that person has already a pair, then you consider inviting the conjugate also, the boyfriend, girlfriend, or the spouse. Okay, now we will use this for this 3.4. Let me see what question I want to go over from here. Number 359. Number 3. They give us the zeros are x equals to 2, x equals to -2 minus 5i with degree of 3. We have only 2 zeros. Actually, implicitly, they tell us another one. By conjugate zero theorem, then x equals to -2 plus 5i is also a 0. Okay, so can we get that polynomial? The polynomial Therefore, maybe before that, those are the zeros. So the factors are x minus 2, x minus -2 minus 5i, x minus -2 plus 5i. Okay, so let me simplify that a little bit. Those are the factors. So the polynomial fx will be leading coefficient times x minus 2 times x plus 2 plus 5i, x plus 2 minus 5i. Now, this is what we call linear factor. Okay, now our textbook specifically say that find the polynomial with leading coefficient 1. That's why our textbook use a equals to 1. Okay, and express fx as a product of linear or quadratic polynomial with real coefficients. Now, these are not reals. That's why our textbook will, so I adjust that with our textbook. Our textbook will multiply that. So fx equals to x minus 2. But because this has complex numbers, then it will make it like this. X plus 2 squared minus 5i squared. It's difference of squares. Do you notice that? Blah plus blah, blah minus blah. Do you see that? Okay, so our textbook going further, that will be x squared plus 4x plus 4 plus 5. I'm sorry, plus 4 plus 25. Okay, so that will be x squared, x minus 2, x squared plus 4x plus 29. Now, this is what they meant by quadratic polynomial with real coefficients. With real coefficients that are reducible. That are not factorable over over real numbers. Okay, but usually in my test, what I want is something like this. This is the one I want. That are irreducible. That's right. That are irreducible. Means we cannot factorize it further. We cannot factorize it further using real numbers. Irreducible over real numbers. Now that's an abstract algebra terminology. Will this be in test 1? No. The material for your test 1 ends on 2.7, 2.6. Yeah, starting from 2.7, there will be your test 2. Yeah. So your question already answered last week. Okay, even more than that. Even more than that. Maybe 2 weeks ago. Yeah, 2 weeks ago. Yeah, we are done with the material for test 1 2 weeks ago. So if you don't do well with your test 1, I don't know what to say. You'll have so much time to study, and you also have at least, you have 5 old test 1 that I work over on my Monday, Wednesday recording. That's number 3. Let's see further. I will just do the linear factoring. Okay, I will just do the linear factoring. I don't go to the quadratic polynomial with real coefficients. Number 5, the zeros are x equals to -1, x equals to 0, x equals to 3 plus I, and the degree is 4. We have 3 zeros here, but one of them complex. So we have something for free. That's 3 minus I is also a 0. Okay, so the factors are x plus 1, x minus 3 plus I, x minus 3 minus I. So the factors are x plus 1, x minus 3 minus I, x minus 3 plus I. So what is the polynomials? The polynomial will be a times x plus 1 times x minus 3 minus I times x minus 3 plus I. That's the linear factor. Okay, now if we want, if a equals to 1 and need quadratic with real coefficients, that are irreducible over R, means not factorable over real numbers, then we get that polynomial to be x times x plus 1 times x minus 3 squared minus I squared. Again, I use difference of squares there, which is x times x plus 1 times x squared minus 6x plus 10. Yeah, 9 plus 1. That's how I get that 10. I squared is -1, so negative I squared is positive 1. Okay. That's for number 5. Last one, number 9. Number 9, the zeros are x equals to 0, x equals to -2i, x equals to 1 minus I, with the degree of 5. So once we see a complex 0, the conjugate must also be a 0. The conjugate must also be a 0. And the factors are x plus 2i, x minus 2i, x minus 1 minus I, x minus 1 plus I. So the factors are, I fix this, x minus 1 plus I, x minus 1 minus I. So the polynomial will be, the linear factor will be a times x plus 2i times x minus 2i times x minus 1 plus I times x minus 1 minus I. That's the linear factor form of that polynomial. This is the linear factor. Now, I don't really emphasize the quadratic polynomial with real coefficients that are irreducible over R. Why? Either you write it in linear factor or you write it in full polynomial. Like you multiply that out. Usually that's the case. Okay, now suppose we want to multiply this out. How will we do that? I will multiply this. This will be x squared minus 4i squared. This will be x minus 1 squared minus I squared. Okay, so this is a times x squared plus 4, x squared minus 2x plus 1, that's plus 2. Now, how do you multiply this further? That's a challenge. Suppose I want to write this as a times x to the 5th, so on and so forth. How do you do that? And after that, just multiply by a, right? Okay. Then I will keep the x first. I will foil this. It will be x to the 4th. I think I did this with the other class. Let me show you again how to multiply this fast. We call this fast FOIL. So degree of 4 only comes from here. That's why we know it must be x to the 4th with coefficient 1. Now, how about degree of 3? Degree of 3 must come from this and this. That's how we get degree of 3. So that will be plus, oh, I'm sorry. No. The second one is not. Only this. Yeah, that's the degree of 3. So it must be negative 2x cubed. How about the degree of 2? Degree of 2 must happen with this pair, this guy and this guy. That's the way we get degree of 2. There's no other way, only this. So 2x squared plus 4x squared, that will give us 6x squared. Anybody taught you this before? Okay, so don't tell me about shortcut until you see all my shortcut. Okay, how about degree of x? Just x. X only this way, no other way. So that's minus 8x plus 8. So if I multiply that all the way, I will get a times a to the 5th, x to the 5th minus 2x to the 4th plus 6x cubed minus 8x squared plus 8x. That's how we get the general form of the polynomial, okay, in descending order. Next, rational zero theorem. This is one of the most important theorems that you need to know. Let Px be a polynomial with integer coefficient. So no fraction. The coefficients has to be integers. Then if C is a rational zero of Px, a rational zero of Px. So it is a zero and is a rational number. Then C must be plus or minus a factor of the constant term over a factor of the leading coefficient. Okay, let's do, for example, number 19. Let's do number 19. For example, number 19, let Px be, I borrow the polynomial, x cubed minus x squared minus 10x minus 8. Okay, what rational zero theorem says? It says that if C is a rational zero, then C must be plus minus a factor of 8 over a factor of 1. That's plus minus factor of 8, 1, 2, 4, 8. Factor of 1, just 1. Okay, so the possible rational zeros for this polynomial is plus minus 1, plus minus 2, plus minus 4, plus minus 8. And no other way. In other words, we know for sure that 5 is not a zero of this polynomial. It won't happen. It won't happen. 3 is not a zero of this polynomial. 2 over 3 is not a factor of this polynomial. It won't. Okay, I think I need to add something more with no common factor. Hold on. Yeah, with no common factor. With no common factor. Okay, so the integer coefficient has no common factor. In other words, if we try to find the zeros and we assume the zeros are integer, then these are the numbers you try. If we need to do trial and error, then we will try these numbers. You don't need to try 3. You don't need to try 6. You don't need to try 5. You just try 1 or 2 or 4 or 8 with plus minus. Okay. Now remember in 3.3, let me go back. Okay, let me go back. In 3.3, notice that for number 29, for example, right? They give us a polynomial and they give us some of the zeros, not all, right? Number 29 in 3.3, number 27 in 3.3 also, right? They give us the polynomial and some of the zeros. In 3.4, we need to get all the zeros ourselves. In 3.4, we need to get all the zeros ourselves. Okay, and usually we start from rational zero theorem. Okay, usually we start from rational zero theorem. Okay, let's just continue from this number 19. Okay, suppose the question is sketch this graph, sketch the graph of this polynomial, which is a very big question. Now to answer that question, we need to do a lot of things, a lot of things. One of them is to do rational zero theorem. Okay, one of them is to do rational zero theorem. Okay, these are the candidates for the rational zeros. Okay, now suppose I do it on my scratch paper. I want to find the rational zeros. Then let me try 1. Let's see if it works. 1, 1, 0, 0, negative 10, negative 10, negative 18. No, 1 is not a 0. How about 2? It's not a 0. Should I try 3? No, don't try 3. Yeah, because 3 is not in the list, right? I say don't try 3, I write 3. I will try 4. 4 is the next positive number in the list. So Thomas, we just keep on trying? Yes, you just keep on trying. So notice that 4 is a 0. right? Should I try 4 again? Should I try 8? Hold on. Take a look on the Scarce rule of sign. The Scarce rule of sign says how many positive zeros? The Scarce rule of sign says, let's see how many times the sign changed. Only one time, right? So only one positive zeros. And what we did just now, we get that. What is that one? That positive 0 is 4. Now you can try other 8, for example, but it won't work anymore. Why? Because there's only one positive zeros. Okay, so using this rational zero theorem, we get that list, and then we check whatever you can randomly check, right? Okay, you don't need to start from 1. You can start from 2, or just go ahead with 4. Okay, so I get x minus 4 times 132. X squared plus 3x plus 2. Oh, that's already quadratic, so I can just factor it as usual. Okay, so notice that the zeros are x equals to 4, x equals to -2, x equals to -1. All of them are rational numbers, and all of them in this list. So you see how much this rational zero theorem helps, right? It helps us finding 1 zeros, and with the help of little help from the Scarce rule of signs, we know there's only 1 positive zeros. Okay, and using that 0 that we found earlier, we are able to reduce degree of 3 becomes degree of 2. And once we get degree of 2, we can reduce that further, either by factoring, like in this case, or completing the square, or by formula. Now, do you realize that we already find out the zeros and therefore the x-intercepts, right? And of course, we can see the y-intercept and we can graph that. So you see, we start from what? We start from rational zero theorem. We just try to catch one of the culprit, right? Once you get one of the culprit, you may be able to find the rest. Okay, just interview that one guy. Like, hey, you know what? Who did you work with? Blah, 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 blah. You interview that person. Okay, in Indonesia, that the police may even use some violence to make you speak out. Okay, yeah. And then that's Indonesia though. Okay, it's a 4 here, -1, -2. What's the y-intercept again? +8, I think. -8. -8. And all of them has odd multiplicity, huh? So it will be like this. Yeah, you can do the sine graph first. You can do the sine graph first. But I believe that's what it will look like. That's the graph. Okay, and it all starts from here. It all starts from here. That's for number 19. Let's do more. Number 20, maybe number 23 or number 21. Number 23. Let's do number 23 first. Number 23. We have that polynomial px equals to x to the 4th plus 3x cubed minus 30x squared minus 6x plus 56. Okay. What they ask us to do is to find, so basically solve, that's the question from the textbook, solve px equals to 0. Basically find the zeros. Okay, but what I want to do instead of finding the zeros, I want to do even more. Can you graph this polynomial? Okay, that includes finding the zeros, and therefore from there we get the x-intercepts. Okay, so usually we start from the Scarce rule of sine. You know, the Scarce rule of sine, number of positive zeros, how many? How many number of positive zeros? Change of sign 1 and then 2, only 2 times. So number of positive zeros, either 2 or no positive zeros. How about number of negative zeros? Let's take a look on p negative x. P negative x is x to the 4th minus 3x cubed minus 30x squared plus 6x plus 56. The number of times the sign changed, 1 time here and then 1 time here. So 2 or 0 again. 2 or 0, negative 0. Even though we have degree of 4, but at most 2 positive zeros we get. Now, how about rational zero theorems? The possible rational zeros are plus minus factor of 56, 1, 2, 4, 8, 7, 8. Let me write that 7 first. 8, 14, 28, 56, factor of 1 on the denominator. So the numbers on the top are factors of the constant. The number at the bottom are factors of the leading coefficient. Okay, now then let me rewrite that. That's plus minus 1, plus minus 2, plus minus 4, plus minus 7, plus minus 8, plus minus 14, plus minus 28, plus minus 56. Okay, now let's do the trial and error. So 1, 3, negative 30, negative 6, 56. Now what you want to divide that by? Can you guess a zero? Do a random guess. Let me try 4. Okay, let me try 4. Maybe that's a 0. I don't know. Oh, it is. Oh, wow. I guess it right. Okay. What happened if you don't guess it right, Thomas? Well, then you may be able to use intermediate value theorem. Now, this happened to be right. Okay, this happened to be right. Now, because we already have 1 positive 0 here, you need to look for the other one. Because we already have 1 positive 0, you need to look for the other one later on. Okay, but if you notice that, so if you notice that we now have px equals to x minus 4 times x cubed plus 7x squared minus 2x minus 14, which we can factor by grouping. Do you notice that? So we get px equals to x minus 4 times x plus 7 times x squared minus 2. Okay, so the zeros are x equals to 4, x equals to negative 7, x squared minus 2 equals to 0, so x equals to 2, x equals to plus minus square root of 2. So the other 2 zeros are radical 2 and negative radical 2. Those are the zeros. All of them with multiplicity of 1. Now let's see This could be heavy, but I want to confirm that what we learned so far still match. Okay, what we learned so far still match. Notice that of these zeros, which of these zeros are rational? Which of these zeros are rational? 4 and -7. Are those rational numbers 4, -7 in the list? 4, +4, -7, right? So it confirms our rational zero theorem. Next, how about, does it satisfy the Scarce rule of sign? The Scarce rule of sign says it should have 2 or no positive zeros and 2 or no negative zeros. The 2 positive zeros are these. These are the positive zeros. And the 2 negative zeros are this. You see that? It also satisfies conjugate zero theorem. Notice that these two guys are conjugate to each other. Okay. Now, with those said, then and we have 4 zeros, which satisfy fundamental theorem of algebra. Okay, so if I want to graph this, let's see what's the y-intercept. Is positive 0,56. The x-intercepts are 4, 0, -7 zeros, radical 2, 0, negative radical 2 zeros. Where do you get that, Thomas? Oh, from the zeros. Okay, all those zeros are real numbers, so there must be x-intercepts. Okay, now I want to sketch them. -7, negative radical 2, 0, radical 2, 0, 4, zeros are x-intercepts. 0.56 is the y-intercept. All of them multiplicity of 1, degree of 4, right? So the far end behavior is infinity, infinity. So it will be like this. All of the multiplicity of 1, right? You can do the sine graph. You can do the sine graph and observe that's the case also. Okay. Now, let me do one more problem. I have only 1 minute left. So how do we answer the question? So I will leave this to Monday. I'm sorry, to Tuesday next week. Okay. So on Tuesday next week, we will have a little bit more. But tomorrow, I'm sorry, on Monday then. On Monday, I will start working on problems from my old test 2. I will start working on problems from my old test 2. And the focus will mainly, especially with the polynomial, because once we are done with this, we are actually done with the polynomial part. Okay, in my test tool, I usually have 2 questions regarding polynomial, specifically on polynomial, and some other problems with polynomials involved. Now, so I will leave that number 27 to Tuesday. Okay, I will leave number 15 also to Tuesday. Let me do number, you know what? Let me leave number 13 to Tuesday instead. Let me do number 15 now. Number 15 is actually on the easy side. Number 15, show that px equals to 5x to the 4th plus 3x squared minus 5 has no rational zeros. How do we show that? Well, we use rational zero theorem. By rational zero theorem, if it has rational zero, then the rational zero will be plus minus a factor of 5 on the top, that's 1, 5, and a factor of 5, the leading coefficient. Okay, so the factor of 5, then divided by the factor of the leading coefficient. So the possible rational zeros are plus minus 1, plus minus 5, plus minus 1/5. Okay, now then what I will do is to check each one of these possibility. Okay, all I need to show is like none of this 1, -1, 5, -5, 1/5, -1/5 are zeros of this polynomial. None of them. Okay, let's try. So 5, 0, 3, 0, -5. Try 1. So from here we see x equals 1 is not a 0. Is it right? Okay, then you try 5, you try 1/5. If you try 5, you will see it's not 0 also. Even though if you happen to know boundedness theorem, if you try x is a positive number and every number here are positive, then no 0 greater than that 1. So 1 is not a 0 and no 0 greater than 1. Okay, if you look back into 3.3 boundedness theorem, that's actually an easy theorem, but a bit confusing at the beginning. That's why I don't really teach that with the time I have left. Okay, now let me try 5 instead, but you will see that 5 will not work. $640, is it right? 640 times 5 is 3,200. And this will be 3,195. It's still 5 is not a 0. Okay. Oh, actually, we can say one more thing, that this polynomial is an even function, right? Because it is an even function, then if 1 is not a 0, then -1 is not a 0. That's an even function. You can just try it though, just the way I tried that one, but you will see the conclusion that x equals to -1 is not a 0 either. But it has something to do with the fact that it is an even function. X equals to -5 is not a 0. Wow, Thomas. So when do we use that even function? When you realize that. Okay. But is there any clue that we need to use that one? There's no clue. It's your intuition. You have to practice a lot. Okay. It's like those are the tools. That's not the end. That's not something you use only when I tell you to use. How about 1/5? Let's try 1/5. You will see 1/5 will not work either. Okay, so from here we see that 1/5 is not a 0, and therefore by even function fact that x equals to 1-1/5 is not a 0 either, because that function is even. Now we have shown that of all possibilities of rational zeros, none of them work. Then we conclude this Px has no rational zero. In short, how to show that a polynomial has no rational zeros? You list all the rational zeros, possible rational zeros, and you try one by one, none of them work. Now, why here you don't show -1, -5, -1/5 times? Well, because it happens that the polynomial is even, so I can just look at the reflection and know it won't work. Okay, now I will stop here. Tomorrow, Monday, Wednesday class have a test. And actually, if you think you are ready, you want to take the test earlier, just take it with Monday, Wednesday class. Okay, tomorrow. But tomorrow, you will look at their notes on March the 22nd one. They start at 9:30. The check-in start from 9:15. Okay, you can look at theirs, but I think you want to do it on Thursday, right? Okay. If you are not a morning person, like very early morning person, you prefer to take it on Wednesday, then yeah, fine, you can do that. Okay. If you want to wake up at 7 something and then start the test at 8 o'clock, then you do it with your regular time on Thursday. Okay. See you then.
Thank you, sir.